We're going to be digging in today into the Common Core practice standards mostly. We're going to be looking at something called problem solving. I know you all do it. And we're going to talk about that, what I like to call in most of my schools, DI, or differentiated instruction. So that'll be our focus for the day. I'm currently not a full-time teacher, but I currently coach teachers. If I'm not doing something like this, facilitating, I am at Collegiate American School, where I collaborate with anywhere from K to 8 teachers. And that's anything from, we focus more on cognitive coaching. So it's going in, planning side by side, co-teaching, or I'll teach a lesson they watch, or they teach a lesson I watch, and reflecting on that. So today when we get to differentiated instruction, I'm going to show you a recent lesson I had a chance to do with a 4th grade colleague on division and how we came up with and shaped differentiation within the classroom based on levels. All right, so that's a little bit about me. Again, good morning, welcome. Let's find out who's in the room. So where are early years? KG, grade 1, grade 2. Working with early years. Oh, whoa, it's a lot of you all. Welcome, good morning. Very important. Foundation is critical and crucial. Critical and crucial. Some KG teachers I work with at Collegiate American School. So going in and watching math talk. What does that look like and what does that sound like? So getting the students to use and math talk. Who's 3, 4, 5? 3, 4, 5. Also very important. All in the middle of elementary. Welcome, welcome. Who's 6 to 8? Where are my middle years folks? Awesome. Today's elementary focus, but there is stuff that's relevant for middle school. I've been a coach, K to 8 mostly. K to 8 mostly. Who are my high school folks? High school, you're great, good. Some high school folks here. Any curriculum coordinators, math heads of departments? Come on, raise them high, raise them high. Math heads, you're doing something with curriculum, something with teaching and learning, something with assessment, all right? Awesome. Any data folks? You might have that role also, any data coordinators, because they usually give the math folks the data work, right? Most of the schools. All right, good. So we have a mix in the room. Like I said, threefold in terms of our focus today. Common Core state standards, looking at the practice standards, finding out sort of where you all are at with your teaching and learning around the practice standards mostly. I feel a lot of schools, what I found is the content folks will have. So I know what my kids need to know in grade 3 and grade 6 and KG. But the practice standards, we'll look and see what around the region that looks like. We'll look and dive into problem solving. And then we'll look finally at differentiated instruction. My big thing with math is it's all about doing math. Those are two things I always look for. If I go into a math classroom and the teacher's doing all the talking, I kindly and politely, as I did last week twice, get up and walk out of the math classroom. Why do you think that? Why do you think that? Say again? Boring. Why else? Not student-centered. Why else? Can't teach it verbally. Why else? Shout them out. No differentiation. Why else? Shout out. Whoever's doing all of the talking is doing all of the thinking. Think about it. Okay? And a big shift in Common Core is getting my math classroom turned into a thinking classroom. A thinking classroom. So when we get to problem solving, we're going to talk and look at some of those things. So here's your warm-up. I need 10 groups. 5 on this side, 5 on this side. 10 groups. So you have a little math to do because you got to figure out how to make 5 and how to make 5. So you'll need 5, and this is what the materials you need. You'll need 5 pieces of chart paper over here and 5 markers, and there's some up here. 5 pieces of chart paper over here and 5 markers. Same thing up here. So one of you, once you form your group, will need that. 2 things I want you to talk about in your group. Who's been teaching math for 5 or more years? Raise your hand. 5 more years. All right. 10 or more years. 15 plus. I know I might look young. I'm not that young. 3 years or less. Wow. Who has never had Common Core math training stand up? Never had Common Core math training stand up when formally. Common Core math training. You've never had Common Core math training. This is my data. I'm getting data off of you all if you didn't know that. Collecting some data. I've never had Common Core math training. All right, awesome. Have a seat. That's the majority of y'all. That's good to know. That helps me. So what I'm doing right now, just in case you did not know, I'm collecting data off of you because that helps me frame today based on needs. Now your questions I've input, well, I'll listen to the conversation discussions and put your questions and things too. You'll notice that. So again, this is a PowerPoint, but we don't have to file this. All right, so that's good to know. All right, your task, 5 groups, 5 groups, 5 chart piece of paper, 5 markers. Chart, piece of paper, 5 markers. Task. What was math like before Common Core? So what were you doing? What did it look like, sound like, feel like? And what is it like now? So what does it look like? What does it feel like? So you need 5 pieces of paper, 5 markers here. 5 pieces of paper, 5 markers here. 5 groups, 5 groups. Ready, set, yellow. Go. You need to form 5 groups, 5 groups. Introduce yourselves, because you're going to be with colleagues who are not from your school necessarily. Make sure you introduce yourselves. I just heard a colleague say, remember, I'm going to collect data on you. I'm not saying who it was. We were teaching California before Common Core. All right, that is time, time, time. So let's have, listen closely, let's have one person from each group come on up with the sheet of paper. I want you lined up in the front. Come on. So we're going to look for some patterns. Awesome, already up. Here we go. There's 1. Who else is coming? Yellow. Come on down. 2, coming on down. Bring one person with the piece of paper. Here she comes. I see her. 3. Right in the front and center. Come on. You can pass it to someone else. You were doing all the writing. You should pass it to someone else. I have 3 people. I need, I think, 7, 8 more people. Oh, I like this strategy. I don't want you to see the answers. Coming, yep, come on. Thank you. Coming, thank you. They're sending you down, I see. Come on, who's coming? One person, yep. One person from each table. Yep, come on. You're invited, come on. Some of you are hiding your stuff. Thank you very much. Come. Oh, thank you. I like you've joined her. Thank you from this table over here. Thank you all. Who else? Who we're missing? 2 more? Come on. I think that's everyone. 1, 2, 3, 4, 5, 6, 7, 8, 9. Come on. I see you. Come on. When you're done, come on. Okay. I think that's everyone. Got you. Is that everyone? She's coming. All right, so before, listen closely, see if these were some of the same things that you all said. Before, I see memorization. Everyone agree? Agree. I actually still see it, and don't play. You do see it too. Tell the truth. I still see PEMDAS, and just remember these rules, and do this, these methods, and the students don't know exactly what they're doing or why they're doing it, okay? Big before, look at this. No understanding. So go back to those procedures. Do step 1, step 2, step 3. Things are in isolation. Big thing, look at this. Teacher-based work or textbook-driven. Agree? I definitely agree too. Watch out. I know some schools. I was talking to a school a couple of days ago, and guess what she showed me with her curriculum map? Chapter 1, Chapter 2, what came next? Chapter 3, what came next? Keep filling it in. If you have a curriculum map that's laid out like that, we need to have a look at that. It's not about Chapter 1, Chapter 2, and it's not about finishing a book either. Okay? Good. Let's see. Worksheets. Lots of them, right? You know, the smart students, you know what happens, right? Some math classrooms, they like to say, oh, you're finished? Guess what? I have another sheet just for you. Then guess what? You're finished with that one? I have another sheet. The smart students, you know what they do? They slow down. I didn't finish. What are you talking about? No, I'll take my time. Because if they think about us. They say, if I keep finishing this, he or she's going to give me more sheets. So let me be Okay? Be careful. Worksheets. I give you one. I keep giving you one. Wait, say again. Say again. Right. Oh, I like this one. Regional. Regional. Tell me more. Tell me more. Regional. I like that one. No one else has that. I'm looking for outliers, too. That might go.
As compared to international.
Uh-huh.
So just area specific.
Area specific. Got you. Perfect. All right. Before. No activities. Come on now. Oh, thank you. Come on. Join us. Now, think about it. All these applications, these iPads, let's be honest. Dojo, we were talking about this morning. Khan Academy, that stuff was not out decades ago. Think about it. I had the book. I had some simple things. I might have made up some math songs. That point so geometric. You know that a line can't handle it. Things like that. But there weren't a lot of all these online things, okay? No real life. No real life, okay? So what about after? So we'll have you go down the row, share something that you put for Math Common Core right now, from this way all the way down. So what'd you put for right now? What are things you notice now? Okay. Yeah, so way more in terms of hands-on, in terms of where it's manipulative, things of that nature. Awesome. Yes, and after. Tell us a right now, a math now. Yeah. Good. Yeah. Good. More interest. Good. We're coming to your class. I like that. Look. Yeah. Ah, yes. I like that. So is everyone in here doing that? I know you're not. Tell the truth. Tell the truth. I'm trying to get most of my schools there. It's nice to know that in science, if we're talking about bridges, guess what? We could talk about math. Bridges. Exactly. So integration. How many of you are also science teachers? You're teaching science and math. Anyone? A few of you. Okay. Good. Or if you're elementary, you have to have everything. Yes. And after. Yes, friendly terms. If you have not, have all of you went to North Dakota's website? North Dakota? I heard a yes. Who said yes? Yes. Who said yes? North Dakota? You say yes? What do they have on North Dakota's website? She didn't. I was coming to her. She's like, don't give me that microphone. They have all the Common Core math standards written in kid-friendly, easy-to-understand language. I can statements. Already done for us. Been done for us years ago. Very easy. Don't worry, I have it up here. I'll show it to you, too. It'll be in the PowerPoint, so you have the link if you haven't seen it. One thing now. Perfect. Very important in all things. Yes. Talk to us. Yep. You. Same thing? Something different. Oh, she's accusing you all of, she's accusing them of academic eavesdropping. We don't call it copying. We call it academic eavesdropping. She heard something that sounded good, so she wrote it down. She was academic eavesdropping. We have a word for it. Go ahead. Mostly the same. Okay. Yes. I like that. So students are carrying out plans. They're doing the plan. They don't give up easily. Thank you. Have a seat. Thank you, thank you, thank you, math colleagues. Clap for them. Thank you all for being risk takers. I like when people say, no, no, don't give me the microphone. Don't call me up. It's all about being a risk taker. When we look at Math Practice Standard 1, it's all about taking risks and persevering. All right? So notice a lot has changed. So when I'm going to sort of go through, I won't take too much time, but I'm going to sort of highlight some things that I might not have heard in terms of Common Core. Might be things dealing with language. So you've all seen this, right? Where's mine at? I have one that I've been carrying around for 6, almost 7 years. A long time. It's somewhere around here, and I can't lose it because I left it at a school the other day. But that's the front of it. Very important. Pages that schools, I've noticed, have been missing. There's 3 pages around page 6, 7, and 8. Very important. They're actually in your packet, and we're going to look at those today. Big thing here. Standards. How many categories? How many bold black things do you see? Don't count design organization. 2. What some schools, I didn't say all schools, I didn't say your school. Some schools went right to swoosh. In 3rd grade, they need to know this. In KG, they need to know this. There's 2 to 4 things they need to know. Okay? So what's the math my students need to know? And skipped this. Okay? When we look at the shifts, there's a big, huge shift in Common Core math. It's called the mathematical practice standards. Those are explicit to be taught. And when I show you the lesson later on, you're going to see how we explicitly put those in there. Okay? When I show you the pictures of around the region, what it looks like, it's explicit. Students to know these 8 habits that help me out as a mathematician. Okay? Key shifts. There are really 6, but they're chunked into 3. Focus, coherence, and rigor, which we'll talk about in a few. Now, I want to show you all 6 shifts. Keep in mind, 1 is focus, 1 is coherent, 1 is rigor. Now, there are 6 of these that are shifts. Now, before I said focus, right? Focus is there. I said coherence, right? What do you think these 4 deal with? Language, good guess. There was another word I just said. Rigor. Thank you. A big shift in Common Core math. Again, I'm looking for things I may not have heard on your charts. Big shift is on rigor. Rigor in the tasks I give my students. So I just can't just assign them math. I have to be looking at what's the math that they're doing and at what level of thinking is required. Okay? Also, I need to be thinking about conceptually where they're learning. You said real world. You said problem solving. That's still there. Okay? Big shift is right down here. Number 6 is saying that these 2 are equally important. As they're solving a problem, they're also making sense. They're also attending to precision. All 8 of these are going on at the same time. And our task as math teachers is to make sure students know this and can do this. Okay? So we're looking at that in a few. This is grade 1. This is all the math they do. But there's also something else sitting over here. Those are the 8 math practice standards. So what we're looking at in a few. And all 8 of those are taught from KG all the way to grade 12. So imagine if every year your students were taught these habits of what to do when you get stuck, what to do, how to use math language and things. Okay? Version 1 is way more elementary from like sometimes grade 2. This depends on language for your students. Because my big thing is the students we collaborate with, language. They have 2, 3, 4 languages. English is one of them. So this one is more grades 2, depending on the language of your students, on up. This is way more kid-friendly, easy to understand language. And like this group set up here, I cans are used. I cans are used. I can, because it's personalized learning, okay, specific for the students. All right, so when you look up here, we're going to jump into those in a minute. When you look up here, what are some words that stand out to you? What are some words that pop out for you? Makes sense. What else? Strategy, strategically. And number 5, what else? Model. That's a tricky one. A lot of times people think, ooh, I as the teacher have to model. That's not what it means. You'll see it in a minute. What else? 10. Reason. Express. Reasoning. Look at number 3. Critical. Critique. Notice 3 says argue. Students are supposed to have a chance to argue in math. Okay? Any other questions? Things you notice? Paper, no pencil. I didn't say that. Put them down. So tell me, let's reflect now. Let's take a step back. What was some of the thinking you either said or you heard? What was some of the thinking you either said or you heard when you talked to a partner? Talk to me. Thinking you either said or thinking you heard. Talk to me. Yes.
We talked about the number of days in one calendar year.
Yeah.
So it's 365. We agreed about that.
Yeah, so you agreed about that?
Yes.
Okay. Anything else? Any other thinking? Yep. Anything else you thought or anything else you said? Coming around. Again, thinking, not an answer.
I know we said we'd have the students draw pictures, maybe on 2 different pages, and kind of, maybe a box with a 12 that represents the 12 months in a year, and just draw,
Yeah.
and then calculate, but draw pictures as well.
Awesome. So getting into like different strategies in terms of whether it's something concrete or representational.
If they can use estimating to find the number of days.
Good. Notice I explicitly said that. A lot of students don't do that. They normally run right into let me find an answer without even thinking about what would be a wrong answer? So here's a question. 1 million is probably a wrong answer, for me at least. Thinking, what thinking did you say or did you hear?
Well, what if someone was not born 9 months? Is that counted? Or like you're asking for days, not years, so that
Correct.
you have to count the days. So what if
Correct.
someone was born 7 months? So is that count? How are you going to be counting? So you still have to count the days.
Right, true, yeah, good. So that was the thinking that you were thinking about, exactly. What else? I heard someone else. Come on, where'd she go? Where'd she go? Where'd she go? Hand up or stretching? I saw my hand up or stretching. What else? Other thinking you did. Part of it was I heard a question. Who asked? You asked the question, right? Yeah, that was your right. Exactly. That was the first you said was I have a question. Other thinking. Again, not about a solution. A lot of this background work, students who struggle with math don't do this. So we have to do this. It has to be explicit. And we do this so much to the point where they start to do it themselves. It becomes a habit. Okay? Any other thinking? All right, so you have math practice standards. What I want you now to do is I want you to think about what we just did, and I want you to look at these 8. And I want you to reflect and say, which of these did we just use? So in the how many days have you been alive, which of these did we just use? So have a look at your tables. I'll give you about 3 minutes. Which of those 8 practice standards did you just use with that task? Think about it. So a lot of times you have to just reflect on the entire thing you did. What did we just use based on how many days you've been alive? So have a flip through, see if you can figure out what you just used. Which of those practices? If you have a question, just raise your hand. Which of those practices did we just use in that task? And think about it. Some of you did different things. I heard some of your ideas. Some of you had numbers. I think we all put out a smartphone. So think about what we just did in that short time and what we have to make these explicit for our kids. Your good math kids already do this stuff. It's automatic. But the kids who struggle don't do this stuff. Oh, look at you. You're so smart. Kiss your brain. A colleague has said, but we use them all. We'll see if we agree or disagree with that. Someone said, we use them all. That was her statement. We'll see if we agree or disagree with that. I know, exactly. I know. I'm like, I think she flipped through them. I'm watching her. All right, here we go. Let's vote with our hands and with our feet. Who thinks we did number 1? Make sense of problems and persevere. Raise your hand. Yes, you did. You had to make sense of what the question was asking. You asked questions. And actually, I didn't see anyone say, I'm not doing this. I don't get this. You know your kids are, tell the truth. And a lot of times it's dealing with reading, as my English colleague over here recently has joined us. I love it when English people come to math sessions, because I told them by the end of the day, my vision is to make him a math person. So I'm secretly working on them. How many of us, when we were talking and sharing our thinking, so this time stand up, that was hand up, now this is stand up. Stand up if you felt we had to take words and turn them into numbers, or you turn numbers into words. So did you say something numerical out of your mouth? Oh, 365 days in a year. Oh, I've been alive this long. If you did that, stand up. Stand up. If you did that. If you, in talking to your colleagues, said a number, you turned how many days have you been alive into a number, an actual number. You should have. You should have. Have a seat. How many of you argued, or you listened to someone else, and they either listened to them, you changed your mind, or they changed their mind, so you said something to them that made them think, oh, I didn't think about leap year. Oh, I didn't think about that. Hand up if that's you. Mm-hmm. Mm-hmm. Hands down. All right, model with math. It's not about me. It's not about you modeling. It's about math in the real world. It's all about mathematics taking place connected to something that's real. Is that a real world-based task? Is that something that could be actually asked and calculated and looked at? Stand up. I agree. It's a model. Yep. Have a seat. How many of us use some type of a tool? So something was called out to get you to sort of think about, oh, let me look, oh, leap year. Oh, look at February, 29 days. How many of us did that? Hand up. Mm-hmm. I asked you to. I know, I sort of threw that in there. Precision, it's all about language. It's all about the language of math. It's all about communication. It's all about if there are units that are necessary that we use those. So in your talk, in your thinking, did you use the language of math or the language of time, of years, calendar days, months? Did you do that? Hand up. Uh-huh. 7, all about structure, all about patterns, all about thinking. You might not have did this explicitly, but it may have come out in a question you asked someone, okay? So did you think about parts, a part of the question as a whole? Think about how this connects. Did you think about patterns? Second? Exactly. So thinking about that. Exactly. So how do we define alive in what realm? Yep. So you thought about actually the last question you did actually sort of took us there because you were like, what if it's like 7 is part of a whole? Yep. And the last one, it's all about metacognition, getting students to think about their thinking about their process. Would my answer be reasonable? Does this make sense? Again, similar to a 1. So was that something that we did in the end? Think about it. So someone said, I think we used all of these. And for that task, you actually could have used all of these, okay, depending on the focus. And that's just, how many questions were up here? How many math questions were up here? Oh, no, sorry, these are practice standards, but how many math questions were up here? 1. How many days have you been alive? All right, questions on that. Questions on that. Notice, 1 task. All right, so let's quickly take a little journey. How does math practice standards look around the region? So how are schools implementing this? And then we're going to look at a math task and have you identify some math practices that students will practice doing it. All right, one of my schools, what they did here, actually followed what we did in Baltimore. One of the early adopters of Common Core Math was Baltimore. I worked there for a year. And what they wanted to do was they wanted to focus on different practice standards in different years. So I showed this as an example, and the school decided we want to take months. And each month, we're going to focus on a different practice standard. Now, that's not to say that during October, the students aren't still going to attend to precision, or they're not going to look for and make use of structure, but it's to say, school-wide, we're going to focus October on that. This is another school. What do you think they did? They've taken all 8 and did what? Posted them. They just posted them, okay? So when I see that, I go right to a student, and guess what I ask? What does it mean? Do you know them? Are you using them? Here's another school, that same school I did month by month. So they've taken, and then they've have samples of student works across the school to show that they're doing math practice standard 1. Here's another school. Notice what they did. Once you look closely at the picture, notice a little dark. Fast fingers. Look at what they did here. They included it where? In the objectives. Remember, dual intensity. So these 8 are just as important as the math content. Look at this one here, primary class. So cute. Look what they did. What are we learning? And look what's right here. Look and make use of structure. Again, front and centers. Kids need to know these and need to know what they're doing with these. Look at this right here. I think somebody said they were grade 5 or 4, 5, 6. Starting to embed this on a task. These things have to be made explicit. This is one of the shifts. All right, questions? So those are just some samples of what other schools and sites are doing around the region. Here is your task. In your packet, so in yellow, some have yellow, some have blue, there are some sample math tasks that I want you to take a look at. Sample math tasks. So for this, you're going to need sample math tasks, and you're going to need your 8 practice standards. So for this, you're going to actually do some math, and then after you did the math, or while you're doing the math, I want you to be charting down which math practice standard am I actually doing, okay? Again, it's all about dual intensity. So there's one called part, whole. There's a subtraction one, and there's 2 that are fraction related. So I'll let you pick which ones you want to do. Yeah, so pick solve 2 to 3 tasks. Yeah, so you can pick one, or you can solve from different pages. I'll let you choose. So solve, and while you're solving, I want you to be thinking about which math practice am I actually doing. 2 of these 8 you do every day. Let me see if you can figure it out. 2 of these 8 students do every single day. What do you think they are? Every single day. Every single day. Number one, exactly. Get your brain. Number one, every single day. There's another one. Someone thinks 4, good guess. You're close though. Real close. 6. Every single day in math, making sense. Every single day, you want them to be using the language of math. You want them to be precise. All right, I'm going to give you about 10 minutes. You are doing 2 to 3 of the tasks and then reflecting. Which of the 8 math practice standards am I actually doing? You can work solo, or if you want to work with a partner, you choose. Again, doing math and then reflecting which of the 8 math practice standards am I actually using.
Hi. First of all, I did choose this one. Okay, it's mentally subtraction and addition. I don't know, I use it because when I was teaching it for my students, you know, they were, okay, how we are going to do it mentally. I wanted them to do it mentally, not, you know, calculating and everything. So, I don't know, what I use from the 8th step is I can think about numbers in many ways. In number 3 as well, I can explain my thinking and try to understand others. I used in this one number 6 and 7, which is I can work carefully and check my work. And number 7, which I can use what I know to solve new problem. And 8 as well, I can discover and use shortcuts. Because actually in here, what I learned my students is just look, hello? Yeah. Is just to look at which place that it's changing. Like if it's hundreds, tens, or ones. So if it's tens, they are going to look at the tens chair, add it or subtract it. It's depending on the question, of course. That's it.
Good. Thank you. Stay there. Any questions? Who has a math question for her? Anyone have a math question for her? We'll take it a break. Yes.
Hey, can you explain your number 8? I did this kind of quickly, but could you explain where your students used shortcuts? Because I was trying to figure that out. Thank you.
Bring it back. Thank you. So shortcuts, because I heard
Yes,
you too. I
the
like that.
shortcuts, like in number 5, and as well in the last one in complete the pattern, you know. In number 5, 805 minus 10, okay? They usually, when they say, when they see 0 and, you know, 0 a small number minus a big number, they always get confused, okay, what we are going to do, and they do it with a lot of steps. I just tell them, forget about the 5, just look at the 0, okay, 0 minus 1, of course, you know, it cannot be. So what are you going to do? Ask a friend for a help. So just take a 1 in here, the 0 will be 10, the 8 will be minus 1, that's it. So this is a shortcut, you know. They do all that mentally. This is this is how they use shortcut, I think, in the special cases, you know. They don't have it to write a lot of steps, because what I want them is to use it mentally, to be more quick in calculations.
So efficient. Good. Thank you. All right, and with that, another question? Real quick question? Go ahead.
It's not a question, but I think a shorter way to cross 80 to 79, it will be faster.
Okay, good. So good. Other strategies and efficiency, yes. Quick, short summary. Things we did in the first part. Very important. Come on. I heard you. Look at, come on. I heard you. Come on. You don't have to stand up, but just speak. What did we do during the math practice standards?
Okay, what we did in the beginning, first you showed people who didn't know what is the difference between before the Common Core and after the Common Core. So we pinpointed the important parts, the differences.
Yep.
Then we had to know that if we didn't have the standards of math practice, then we can't go to the content. Okay, then we went on to the big question. Okay, and then you showed this just briefly, and then you went to the big question, and then we went back again to check did we use all of them or not, and then the answer was yes, we used them all. Then we had some of our sheets, the worksheets, just to see if we're going to be able to do it, and then we had an example, the person who was sitting on the mathematical chair, and each of us had to get through the practice, the exercises, and were we able to apply all the 8 math practices? And that was like, in one word, we practiced how to do the math practice.
There, I like that. Can you say that last sentence one more time?
We practiced how to do the math practice.
That's it. We practiced how to do the math practices. That same thing, that task that we just did, where you looked and did math and looked back at your 8, same thing you need to start having the students to do. A little bit older students can do it, of course, with your guidance to start. Way more guidance in the early years. But given that's why I gave you sort of the 2 simple version of the language, depending on your learners and where they're at with language. We also, one thing, we looked at sort of examples of what it looked like across different schools in the region. So here's a question, food for thought. I said when we look at the 6 shifts, 4 of them dealt with what? Rigor. So what do you think are 3 teaching practices you would typically see in a rigorous math classroom? So if you were to walk in a math classroom, what would you expect to see, to hear, to feel? How would you know it's a rigorous math classroom? Say again? They're thinking, student learning. Questions, discussing. Examples, you say achievement-based. Tell me more, what do you mean? Ooh, arguing, material. There. Different questions, models, what else? Good, group work, individual work. Competing, technology, what else? Comprehending the language. Ink, oh, I like that. Struggle is major. Now, I'm going to come back to that one over there. I heard you in that corner. I'm coming to you in a minute. Thinking about reasonableness. I heard worksheets. Let me come over here. Who said it? I know who said it. She's like, she said it. Tell me more about the worksheets based on what you know about the shifts, the 6 shifts, and the practice standards. Oh, she's standing up. Hold on. Let me get the microphone. Hold on. Let me get the microphone. So I don't want to hear just worksheets. I want to make sure when you're talking about a rigorous math classroom, what do you mean by worksheets? Tell us more.
Worksheet means like more of exercises and more, yeah, they will learn more and they will understand every question, like different types of questions and worksheets.
Okay. We're going to hear, I'm glad she said exercises. You're going to hear that word in the audio we hear from Dan Meyer. If you've not heard of or seen, Dan Meyer has probably one of the best TEDx math talks that there are, the TED videos. He collaborated with us with this group I work with in the States called Mid-School Math. So I'm actually going to the States in 2 weeks for their conference in New Mexico. So lots of things you said. Now, not one person said, now, Kevin, what do you mean by rigor? So let's look up here at what it is and what it is not. What do you notice? What it is and what it is not. Look at number 3. Remember earlier I said those, here's some more worksheets. Worksheet 1, you finished? Worksheet 2, you finished? Worksheet 3. Exactly. It's all of demand. It's all of, I shouldn't have to give you 5 worksheets. The first one I gave you should have been that at that level of thinking that was required. Okay? Right. So that's why I asked about that worksheet. I'm like, tell me more about this worksheet and what they're doing. Big difference. So the question is, when we say a rigorous math classroom, are these the types of things that we're giving to our students? Are they reflecting, applying? Are we pushing them deeper For example, this table over here, when we first started this morning, what did I say to you all when I saw your, hold on, this morning they had this much down for their before. What did I come over here and say? Nah. I didn't say nah, you know. But I said, who's been teaching for 5 or more years? You know, are there other things? So again, it's how do I push them accordingly? How do I challenge them? And a lot of times, like you said, is with the questions. So David Ginsburg, he's known in the States as one of the math coaches. This is what he says when it comes to a rigorous math class. Notice, as our colleague says, struggle. Students need to struggle. Huge. You go on NCTM, National Council of Teachers of Mathematics. Hopefully you're a member or your school is. Productive struggle is major. It's not about giving kids easy stuff that they're going to be able to walk through quickly. They need to think about it. They need to struggle. 2, it's about problem solving, process. What did I say earlier? We got to how many days have you been alive? It's not about answer getting. That has long gone. Not about that. It's about the behind the scenes. What is my math brain doing? 3, someone said multiple strategies. So it's not about the teacher's way. You taught me this way. Miss Acapella taught me how to do geometry one way, so that's the only way. No, that's her way, but that doesn't mean that's the only way. Okay? Yeah, so one thing I noticed is how many of us struggle as listeners. Now, I will admit, when I send the PowerPoint, I will send a video. There's a video with this too. Now, the issue is there's so many of us online that the video wouldn't load, and I don't want us to be sitting here waiting for part to load, to stop, to go, so I did the audio instead. So I will send you a link to the video. It's only about 2 minutes and 29 seconds. It's not long. But productive struggle. What were some things that you did here, or things that sort of stood out to you? I heard a colleague over here say she noticed.
I noticed that his point of focus was that we need to know first what's in students' head. Before going on with our lesson or whatever we have to teach, we need to know what's the level of the student, what are their basic understanding. Yeah. And not only one, a lot of students can fail.
I'm stealing it right there, because I think that connects right to what someone else was earlier talking about, data. So how I think about the very beginning, how I sort of collected data, just by asking a couple of questions. Who's that Common Core trainer? Who's in this grade level? So how are you probably collected data about your students. Diagnostic data, there's admission tests they take data. We were talking about that earlier. There's in-class data, if you're doing map tests, Iowa, whatever, external information. How are we using that in the classroom? How are we using that in our teaching and learning? Other things you heard about productive struggle. Other things you heard. What did you hear? Other ideas.
Discovering new ways.
Talk to us.
I think he spoke about discovering new ways and methods of solving some questions.
Yep.
I think that's about it. That's what I heard.
Yeah, that stood out. Other things. What did you hear? Yeah. Yes, ma'am.
Identifying if it's a real problem or if it's just he's at a block or something.
Yeah. Perfect. Other things. What else you heard? And I think one of the things that stood out for me is that last piece, be curious about students. Being curious about what's in their brains. For example, this is one of my favorite math tasks. So, let's read. It says there are 125 sheep and 5 dogs in a flock. And here is your math question. How old is the shepherd? Now watch this. Every time I show this, again, I got this from Phil Darrow, one of the Common Core math authors. Now we all laughed, right? We laugh, but we know and tell the truth. If you were to show this to your students, what might they do? See, and you all are saying at the same time. I don't even need to know what you're saying. They're going to do this, right? Extremely big. I can't multiply. Wait a minute. Okay, that's too big. What is the pattern you're noticing right here? The student's work in this response. Yeah. Multiplication was extremely big. I added, it's too big, still big. What's left? And guess what they'll say? Now, what's wrong up here? They didn't even read the question. Do you now see why answer getting, it's not about answer getting. It's not about having them come up with an answer, because this is what you're going to get. Okay? Remember, it's about the thinking. Think back to that task that we did earlier. If you did not know, NCTM, National Council of Teachers of Math, if you're not a member, you want to join. There's an online version as well. I think it's about $39 US. It's worth it. You get access to lots of materials. They have a definition of problem solving. They have a definition of problem solving. Here, read that for us. Cool.
No, I cannot read from here. So.
You don't have to stand up. You can just read from there. Oh. Yeah, just read that definition.
Reading?
Yeah.
The term of problem solving refers to mathematical tasks that have the potential to provide intellectual challenges for enhancing students' mathematical understanding and development.
Thank you, sir. I want you to notice something up here. Now, earlier we heard worksheets, exercises. Do you see that anywhere up here? No. And I don't want you to think that those mean the same thing. Those are not synonymous. That says mathematical task. Notice how sophisticated this definition is, too. It's not just about the task. So it means I, as a teacher, I did some planning. Not necessarily what's in my book or things. I mean, I could look at that as a reference. But how are the materials and resources that I'm providing students going to intellectually challenge them? Again, if I'm giving worksheet 1, 2, 3, 4, 5, was that intellectually challenging? And how is that going to enhance their understanding? So in your packet, I want you to take this out. It's a sheet in there all about problem solving. It's a sample of a problem solving protocol, if you will. So a process. Lots of publishers, lots of resources have a how-to with problem solving. Now my issue is always, how wordy is it? Because I think your students are probably like my students in Dubai. A lot of language learners. So I'm not coming, I want you to think that, well, he's from the States. I haven't lived in America since like 2005. So the language learners I work with in international schools, it's always how can I give it to them so that it makes sense and they're able to access it? So this right here will give you a sample of a problem-solving protocol. 4 steps. That's it. Most problem-solving protocols are 4 steps. Some are 6 steps. Some might be a little bit longer. But notice the steps. Number 1, read. That tends to be a step that a lot of kids in problem solving skip over. But not only read, it's asking them to do what? Understand. Doesn't that sound like a math practice standard? Which one? Number 1, make sense of problems and persevere. Number 2, ask them to make a plan. Also sounds like a math practice standard. 3, once you have your plan, carry out, do it, do the math. Even though if they read and understand, that's still doing the math. Now we get into like the literacy aspect of it, mathematical literacy. Because Saudi, you all have not been taking PISA, right? I think you're going to be starting to take PISA, the assessment that 15-year-olds all over the world take, the global assessment, part of OECD. And then after that, check. So look back at your work and review it. So I want everyone should have a piece of white paper somewhere on your table. White paper. Each person needs a sheet, so pick it up. Yeah, need a white sheet of paper. If you don't find it, raise your hand. I'll bring it to you. White sheet of paper. Perfect. All right, fold it this way. Fold it this way. Fold in half, then fold it one more time. We're gonna make a who? Paper plane. That was in GSS. I saw those. All right, so what I want you to do is the following. I want you to number each box. 1, 2, 3, 4 on the front. Flip it over on the back. Do the same thing. Number it. 1, 2, 3, 4. So 1, 2, 3, 4. 1, 2, 3, 4. All right, for this next task, everyone is going to need a partner. So you need to be sitting next to somebody, either at your table or somewhere else. So everyone needs a partner. So your task will be, partner 1 will solve the task one way, on one side of the paper. Partner 2 will solve it after they've did theirs. So partner 1 will solve it solo, by themselves. No help. Okay? So you're just as one partner solving, one partner is watching and observing. Okay, questions? After partner 1 is done, switch. Partner 2, it'll be your turn. You must solve it a different way than your partner. Oh, hold on. What? So if they use boxes and squares, I can't use boxes and squares? No. If they use the simple algorithm, I can't use it? No. Questions? Partner 1, so one of you will be partner 1. You'll solve it one way. Partner 2, just watching. Then switch. Partner 2, you've looked at what they did, solve it a totally different way. Oh, good. So let's say this is partner 1, partner 2. Partner 1 will solve it her way on this paper by herself. Partner 2 will solve it on her paper. Then you'll talk about it, switch, and then what I want you to do is see if you can solve it the way that they solved it, if you can understand, but without talking. I will repeat, no talking. Questions on that? I did give you multiple layers of directions, so questions on that. Partner 1 will solve it one way. Partner 2, you're only watching. That's it. No talking. I'm going to give you the questions in a minute, but I want to make sure you understand the directions because they're multi-layered. After partner 1 is done, partner 2 is your turn. You must solve it a different way. Oh, good. What about the boxes? Because you're going to use the problem-solving protocol. Oh. Oh, look at you. The question is, now you know I set this one up, right? Come on now. Look. She said, what if it only has one way to solve it? Guess what? I did all the pre-planning to make sure. All right, ready for the question? If you are partner 1, raise your hand so we can make sure we know who is who. Partner 1, you are now solving. Partner 2, you are observing. No talking. You may watch and look, but no asking. Here is the task. We go. Fiona, listen closely. Fiona has 15 boxes. Listen closely. Fiona has 15 boxes. Shh, listen. Fiona has 15 boxes of flowers for a birthday party. Each box has 25 flowers. How many flowers does she have in all? Now quickly, like I said, partner 1, you'll solve it one way. Partner 2 will watch. Okay? Once you're done, you'll switch. Partner 2, you can solve it. It'll be a different way than them. 2 of our objectives, things we've been working on in math, being able to multiply 2-digit numbers. So if you want to use that as a strategy, that's fine. And then we're going to be looking and listening for attending to precision. I'm going to be coming around to see students who are going to be sharing their math thinking in the mathematician's chair at the end. If you could share what each other did without talking. So partner 1, you may start. Partner 2, you are observing. So if you could test, almost like taking your math block and turn it into a story. So what happens at the beginning of math? Just raise your hand. Tell us. Beginning of math. I heard warm up. True? Yep. Review. What else? Check homework. You don't get into the homework trap. Like I go in and audit math classrooms, and if I see homework for 10 minutes, I'm like, so check that they've completed it. Thank you. Who said 2 minutes? Thank you. True. And part of it could be, watch this, come on up, write down answer homework, and we check based on his responses. And then I sort of going around and checking to see if they did or didn't, but it shouldn't take a long time. I've seen this be 15 minutes in some classrooms. I'm like, Could be right, exactly. But something sort of quick to see who didn't get it, who needs me, who does not need me. What else? Warm up, review, homework, check, quick, homework, check. How's that different from warm up? Ooh, hold on. You don't know what warm up is? Who does a warm up? Because she said she does not know what a warm up is. What's a warm up? Oh, review. You say review? Yeah. Review, warm up. You said startup activity, though. What else? Connection to real life. Video. Lesson name. Might be a story at times. You're so literacy over here. What else? Discussion. I like that. So doing some talking in math. Now we're done? Right. Right. I know I want to laugh too, but I honestly think the same thing. You're like, nah, the lesson is over. Switch. What else? There's something else missing here. Very important. Brainstorming. Someone said grouping. There's something big that's missing here. I heard it starts with an O. Objective. Written as an personalized. If you're not using it, you probably want to start. North Dakota link I'll show you in a few. Brainstorm. About how much time do you spend on this? Ooh, somebody said 5, somebody said 10. If you 5, you have it down. 10, 5 to 10. Now, if you do all this in 5 minutes, I'm looking at you like, seriously? 15? You don't have so much time for 15, I'm going to tell you. I would say 10 minutes is probably your threshold. That's what you can last at, about 10 minutes time. If you have not did this, by the way, you need to time this stuff. Trust me. If you don't time it, you find out, oh, I'm losing. I didn't have a chance to do that. Oh, we missed out. Time these things. That's why I'm having you break this down now. Middle. What's happening in the middle? So I heard instruction presentation. How much time are you spending on that? 15 is too much. Next. 25 too much. Next. 5? That's probably too short. You got somebody struggling there. Probably 10. You talking for 15 minutes? Are you serious? I'm coming back over here. Are you serious? You know, if you only have 40, 45 minutes time, you don't have 15 minutes. You do not have 15 minutes. Trust me. This mini lesson, we're going to call it, instead of instruction, and notice the word in front of lesson, mini. Thank you. Mini lesson should not go past 10 minutes. Trust me. You only have 40, 45 minutes. 10, I would say maybe 12 minutes. Should be short. What else? I see practice, instruction, or your mini lesson. What else? Student got practice, instruction, mini lesson. What else? Guided practice. Talk to me. What else? Solving problems. Thank you. So students are what's the name? What else? That's it? Nothing with a G? Grading. Now, come on now. You're like, grading? You can get, oh, so you sitting down grading while they're over there? No. Group. Oh, I'm glad you said that. Somebody said it's noisy. So let me tell you what I do. Part of something that if you didn't do it this year, don't worry. Next year when you start math, very important that the first 30 days of math is spent each day for a couple of minutes explicitly teaching your students things you want them to do. For example, I want to make sure that if they get stuck on a problem, they know what to do. All this stuff, I don't know why that keeps flipping. You have to teach them how to do. Let's say you want to teach them how to talk, how to ask math questions. It has to be taught to them. You can't expect them, I don't care how old they are, to do this stuff automatically. Okay? So first 30 days of math, starting from, we start school here in September too, like UAE, September-ish? I know it depends on calendar though. But yeah, around September. Every single day for the first month, you want to get them in the habits, whatever you want to see, homework collection. When you work in a group, I got stuck. All those things you want them to do, you have to explicitly teach them every single day. Pick a day and teach them something. Questions on that? Important. Because then you get away from, like you said, with the groups. I put them in a group and then it's like loud and they're boisterous, you know, or they don't know how to control themselves, or they don't know how to work in a group. So you have to explicitly teach them all of those things. Questions? All right, so that stuff has to be taught. Middle, what about the ending? How do you close math lessons? I know how you close. Tell the truth. Tell the truth. I see lots of math classes. Tell the truth. Feedback. Oh, so you got time to go around. Is it oral or is it written feedback? Oral. I knew. Because you only have 45 minutes over there. Feedback. Some type of evaluation. What else? Oh, it's homework. Come on. Solve tasks. Questions. What else? Some type of assessment. Summarizing. Might be questions or quiz. What else? Anything else? Go ahead. So connecting back to the real life. Shh. I'm just going to put questions in general. So solved, tasks, questions. What else? Oh, I forgot this. 10 minutes here. How much time here? 25? So some say 20 to 25. How much here? 5 to 10? Now that's broken down. That total is about 45 minutes, 40 or 45 minutes, depending on how much time you have. Question is, when you think about this block, how does this connect to differentiated instruction? This is what you said. How does that connect to differentiated instruction? So where is the evidence that I did some type of differentiation? Group work would be one way. Evaluation. Solving tasks. Those types of questions down here. Startup activity. Tell me more. So if it's based on their learning, how they learn best. Yep. Others. Where do I see evidence of differentiated instruction? Homework. That's what that. So I want you to look at what you said, and I want you to see if you can make connections to this up here. Let me move this back so everyone over here can see it. So this is a typical, so I was trained years ago in math workshop. You hear a reading workshop, writing workshop, there's also a math workshop model. So have a look at this. I know those times are different. See, that time up there is thinking if I have about 60 minutes for my math block, that's how I can chunk it. So note your opening. You said what, about 10 minutes, right? 10 minutes. That's the beginning of math. Middle, 25 to 40 minutes. Again, depends on how much time. But look at the closing and then look at your closing. You said 5 to 10 minutes. How much time is up there? 15 to 20 minutes. Big difference, isn't it? Now, when you look at all those things connected to closing, who do you think is doing all that? So who do you think is presenting? Who do you think is revising? Who do you think is questioning? Think about what you did today when we did something like this. Who was doing all that? The students. So the closing is not about me. It's about me sitting down on the side. So when you look up here and you compare it to here, a lot of connections. Warm up, objective, discussion, expectations for how we will work. Did you hear me say that today? You'll work solo, you'll work with a partner, you'll work, being explicit so they know exactly how they work. Introduction of the concept. Notice it's there. Within 10 to 15 minutes, short. Work time. Do you see where differentiation would occur? Where would it occur? Conferences, one-on-one. And I'm not talking about with one-on-one up here, I'm not talking about, that's right, that's wrong. It needs to be an actual sit-down conference, one-on-one with the student to find out what he or she knows or does not know, where you give them a task to do and to try. All right? Others, notice it says prepare for closing. What do you think that means? What is that? Think about some of y'all who came up here. Most of you, I asked you, I said, I'm going to have you share that, or I put a little tick on your paper. That's to get you ready. So I'm preparing you. I didn't just randomly say, okay, you over there, come on up here. It's a big difference. So you had time to sort of do your thinking, your pre-planning, your what am I going to say, my rehearsal. All right, questions. Any questions on any of these parts and pieces up here? A lot of connections are similar. Some things were missing, not a bad thing, but again, just to draw your attention to when you look at your math block, planning-wise, how to start to be thinking about, especially when it comes to the time you have, which is short, but how to get pieces in, especially as it relates to differentiation. Conferences, small group instruction being two of the pieces. Any based on anything you see or hear up here? Part one, here's part two. Now notice earlier I said North Dakota. North Dakota has already taken all the Common Core state standards in math at all grade levels and created an I can statement. It's already been done. So that's the link. Again, this will be in the website, this will be in the PowerPoint sent to you. And North Dakota has unpacked all the Common Core math standards. Also English language arts, they've unpacked too. So they're in teacher-friendly language. You read them, you can understand them. Okay? So even if you were to Google North Dakota and Common or and I can, it'll pop up. The same thing with North Carolina. Those things have already been done. So earlier we mentioned planning. Colleague mentioned planning. Said planning. So when you look up here with planning, what type of connections do you see based on the type of planning you are doing? Now, a question with planning is, because I have some schools that have no planning time. I have some schools that have 1 hour per day, so much time, minutes per week. Some that teachers do it on Saturday, so it ranges based on the school that I serve. So, but the big thing is, how are you planning? And then I want you to look up here and see, where do you see evidence of differentiation as it connects to planning? So just take a minute at your tables, talk about that. So have a look up here on the planning. Again, it's this guide, simple, I keep it simple. The standard, but really digging into the standard. What does it mean? Make sure it's kid-friendly. Then I move from standard now to activity, to assessment. How would I assess it? What would I use? To how would I teach it? That's when I get to do my little activities. So that comes third. And then, could this be integrated? Is this relevant to another content area? Is this relevant to science? Okay? Take a minute, talk. I want you to focus on things you see up here that connect to differentiation, and how does this connect to the planning that you actually do? So what evidence do you see of differentiation, and how does this connect to the planning that you actually do? So this right here gives sort of all the different components. I'm going to turn over to Iyad, and then...
Okay, thanks. Thanks, Kevin. As you can see, those are the components of Alpha Math, where we do have the student books that are delivered in volumes. As you saw, we have Volume A and Volume B. Volume A will go for Semester 1 and Volume B for Semester 2. We will have for both two volumes of the practice book. We do have the differentiation book, which is the Enrich and Reteach. Those are coming in two separate components for your students to apply them in classrooms. We have the games and project activity book. We do have the multiple intelligence cards. the anchor activities differentiated cards, and the exit cards, which is the pass that is given to the students that they have mastered the concept and now they can move. The assessment book and interactive games and online resources. And with the last point, what do we have at Alpha? We have something we call it LCMS, which is the Learning Content Management System. So the Alpha Math, or Alpha products actually, all Alpha books can be delivered as in digital or in print. Can be delivered online and offline. So if your school is not wired by internet and you still need your students to access the content, they can access it offline. So there is no need for internet, but still you can use the digital. Your students can access the content through their tablets, smartphones, or desktops or laptops. Once they are wired, the data will be synchronized with the servers, and the teachers will receive the reports. So it's not only a content management system, it's also a learning management system where you keep monitoring the progression of your students by receiving different reports. So you could receive reports by class or by individual. Those reports, back to the data where Kevin started with, would tell you again how are your students' progression through the course, who struggle and why. So you can put the plan for them. Yeah. The differentiated book, the Enrich and Reteach, you spoke. I was within a group here talking about differentiation. We spoke about the differentiation in instructions. We spoke about the differentiation in content. And we do also speak about if I have different students, how can I work with those different students and dedicate time, different times with those students where you can use the enrich and reteach. The other thing that I would like to mention is how to apply. How to apply is equally important to the program. Yesterday I mentioned that we are building on that, where we can come to your schools and build your own training. So if you are interested again and you would like to explore this further, you can speak to us and we will be happy to come and run the training in your classrooms, talking about the Common Core State Standards. How can you change the Common Core State Standards into practices by using Alpha Math, which is based on the international standards of the Common Core State Standards. Okay?
All right, we have
so,
2 more questions.
Yeah, 2 more questions about Alpha. So we will have a question for this part, this section, and a question for the other section, and those are related to Alpha. Okay? So you do have a brochure in front of you. You can use it if you would like, okay? Because it has lots of info about Alpha. And my question, the first one is about assessment. You need one. My question is to this section about assessment. You don't have? Can we? Okay, can you share? Can you share for now, and then we will leave some. Okay, my question, and really be careful. I'm talking about assessment, okay? In Alpha book, the student book, not the assessment book, there are 4 types of assessment. 4 types of assessment coming under 4 different titles. What are those 4? If you won, you have no chance, okay? If you, I have, where? Okay. Okay, tell us.
reflection check, finish line, chapter test.
Okay, that's cool. And we have the checkpoints, yeah? Good. Sorry? The checkpoint, yeah. Excellent. Okay, the second question. A and B. And you need to answer A and B. If your school are not wired, okay, can you access Alpha offline? The second question, okay, which you will get a gift for it, is about the resources. Name for me at least 3 resources other than the student book, the practice book, and the teacher's edition. Any other 3 resources? Hands up, hands up. Hands up. Okay.
Game book.
Game book. You are helping him to win? This is very kind of you. Very kind of you.
Okay. Project activity. Exit cards. So. Assessment book.
Okay, we have a winner here with the help of the whole group. So we come to the end of the day. There is an evaluation form. Okay, if you don't have, we will give you one. If you have an evaluation form in your folder, can you please fill in the evaluation form and leave it on the tables? We will collect them later. The second thing is that you can take the Alpha Mathematics catalog with you. If you are interested to receive samples, there are sample request form in both ends you need to fill in. If you have already filled in one, you leave it on your table and we will collect it. The certificates, we do have some certificates for teachers. None? No, okay, okay. The evaluation form. No evaluation forms. We don't have evaluation forms. No. That's all. Okay, fine. It's a mistake by us. We do apologize. Okay, while Andy is if you have already filled in the sample request form, please leave it on your tables. We will collect them later. Certificates, if you registered online, if you go to training@smarteducation.ae, your certificate is ready, and you can, on the registration table, while you are walking out, you collect your certificate. Don't worry if your certificate is not there. When you came this morning, we do have your emails, so we will send all the certificates to you to schools, hopefully by end of next week or beginning of the 3rd week of February. Okay? Okay, for the evaluation form, it's good for Andrew, okay, that you send him like hundreds and hundreds of emails. This is his email. Okay, send your feedback, please, because this is very important. I do apologize for that. Send to andrew.pinish@smarteducation.ae. If you have any feedback, you can follow us on Facebook, Twitter, LinkedIn, Instagram, and YouTube. Once we have the video of this seminar ready, we will send you the link to your emails where you can access the seminar, you can upload it, and you can share it on your social media channels. Okay, I'll leave it to Andy to close. Thank you very much. It's been great to see you, and we look forward to seeing you again. Thank you.